Happy Word Problem Day! Today we are going to write equations to represent word problems and then we're going to solve them. So the first thing we're going to need is a let statement. Okay, that's worth a point for every word problem. The next thing you're going to need is an equation. That's worth a point. Okay, you're going to have to show your work. Okay, your work and your answer are worth a point, so this is +2. Work is so important. And then you're going to need a complete sentence. And that is worth a point. Whoops, that just says plus. Okay, so this is a total of 5 points. These word problems are huge, okay? They're worth a lot of points, so it's really important that you go through the checklist and remember to get everything. Okay, let's talk about some key words before we dive in. Some key words to tell you that your signs are going to be positive. Okay, would be increasing, saving, earning, depositing, okay, that's obviously not an entire list, but that gives you an idea of what you're looking for. All of those things are telling us that we are like increasing or that a quantity is positive. Okay, so now you can think about the opposite of those, and that would be your list for negative signs. Okay, so decreasing, spending, earning, whoops, not earning, withdrawing, expenses. That leads me to another one that I forgot. I knew I was forgetting one. Okay, up here for positive, profits. Profits and expenses are the opposite of each other. All right, so that was your negative signs. All right, so we're going to look at this first example. We're going to set them up, write let statements, write equations, but we do not have to solve. So we're just going to talk about setting them up. So we've got Harry throwing Hagrid a birthday party costing $300. It's going to cost $100 for the band, and he's buying decorations for $50. Okay, now he's going to spend $3 per party guest on food. We want to know how many guests attended the party. We get our let statement from that question. So it says how many guests. Okay, so that's the thing we don't know. That's what we have to solve for. That's what X has to be. So we have to say let X be our guests. Okay. The next thing I want to talk to you about is some key words. When you're setting up this equation, let's circle some numbers. So we've got 300, we've got 50, we've got $3, and we've got 100. Okay, you'll see the per on the 3. That means that it's not just a regular 3, it's a 3 with an X. Okay, so let's talk about some costs. it's going to cost him $100 for the band and $50 for the decorations. So just to set up the party, even if he doesn't invite anybody, it's going to be $150, right? So even if we have the saddest party ever and 0 people come, we don't buy any food, we still have a band and we still have decorations for $150. Okay, if we invite one person, okay, now it's going to cost us $3 for that guest's food. So that's $153. The $150 didn't change. It's just the $3 for the food that changed. Okay, if we have 2 people, it's going to be $156. We're going to add 3 again because we've got another guest. Okay, so it's not just adding 3 once, it's repeatedly adding 3 for each additional guest that we have at this party. So we have to have the X with the 3 compared to the other numbers. We don't need an X. Cool? Okay. So for our equation, we know that it's a total cost of $300. Well, that's a negative because that's not money that Harry is earning. He's having to spend that. So he's spending $300. Okay, that's the total. Now, what goes into that total? Well, we talked about it. Paying the band, $100. Buying decorations, costing another $50. All of these costs are money going out, so they're negative. All right. Costs him $3 per guest for food. Now, we have some stuff that is combinable. Well, look at this. So we're adding up a bunch of negatives, a bunch of costs. Doesn't it make sense that our total is a big negative number? It's going to be a big total cost. Okay, so let's look at this stuff because it's combinable. We talked about combining the cost for the band and the decorations. So that's negative 150 minus 3x equals negative 300. All right, now look at all those negative signs. They're kind of gross. Okay, aren't we allowed to divide both sides by the same number? What if I made that number negative 1? So now we're dividing the negative 150 by negative 1 and we get a positive 150. We divide the negative 3x by negative 1, we get a positive 3x. And then same thing over here, negative 300 divided by negative 1 is positive 300. Okay, how many of you are sitting there at home being like, I would have just started with that equation? Yep. That's what my math teacher did when I was in school. And I was always really confused about why are we saying it's a cost, but we're putting a plus sign? If you're adding up a bunch of costs and it's all negative signs, you can just not worry about the negative signs because when you divide both sides by negative 1, the negative signs go away everywhere. Okay, but if you've got some things that are profits and some things that are earnings and some things that are expenses, you have to be very, very careful of those keywords. Okay, well, that's all we had to do. We had to write a let statement and write an equation, so we're done with number 1. We don't have to solve that one. Yes. All right, let's look at these little hotels. We've got a table comparing prices for Godric's Hollow Hotel and the Hogsmeade B&B. So for each of them, the first night is $95. Well, one of them's $95, the other one's $65. And the price per additional night, those are $20 and $26. My mouth is not working, sorry. Okay, so as far as keywords go, look at this, price per additional night. Okay, per each and every get the X. So I already know that 20 gets an X and 26 gets an X. And I want the costs to be equal. So I want the cost of Godric's to equal the cost of Hogsmeade's. Okay, they're going to have to be the same. So that's my equation. I'm going to have a Godric's Hollow side and a Hogsmeade side. And I want those two sides to be equal. Let's back it up because I already forgot to write a let statement. I was so excited about the equation. Happens to everybody. All right. The question says how many additional nights? So we know that the x has to answer that question. The unknown has to answer the question because that's what we're going to solve for. So we have to let x be additional nights. Okay, now we can finish writing the equation, sorry. So for Godric's Hollow, it's going to be $95 for our first night and then $20 more for each additional night. Okay, for Hogsmeade, it's $65 for the first night plus $26 for each additional night. Okay, that's our setup. Okay, that's it. Next. All right, guys, now we are going to set up and solve. We're going to do the whole shebang. We have 60 students currently enrolled. In care of magical creatures, and the class size is decreasing at a rate of 5 students per year. We have 40 students taking potions, and the class size is increasing at a rate of 15 students per year. Okay, that was a lot already. Okay, we've got 60 taking care of magical creatures, and it's decreasing at a rate of 5 students per year. Okay, we've got 40 doing potions. It's increasing at a rate of 15 students per year. Those are our two sides of our equation right there. Okay, then we want to know when are the classes going to be equal in size. Okay, look at the question. It says, in how many years? That means our let statement has to be let x be years. All right, so we're going to have a care of magical creatures side and a potion side, and we want the two sides to be the same. So let's start with care of magical creatures, and over here we'll put potions, and we want the sides to be equal. So 60 plus, whoops, just kidding, decreasing means negative, okay, minus 5 students per year. So the 5 gets the x. Okay, it's 40 in potions, but it's increasing by 15 students per year with an x. Now we have to solve it. I'm going to write this. No, I can fit it over there. It's fine. Okay, sorry. Here we go. Now we're going to solve. So I want all of my x's on one side of the equation. So I'm going to subtract 15x from both sides. Okay, these cancel, and I get 60 minus 20x equals 40. Okay, now I want my constants on the opposite side from my x. So I'm going to subtract 60 from both sides to cancel these. Okay, now I get negative 20x equals negative 20. I have multiplication between my negative 20 and my x, so I have to divide to undo it. So I'm going to divide both sides by negative 20. And these cancel. These also cancel. They make a 1. So I get x equals 1. So what's happening is this. Oops. Here's our care of magical creatures. Here's our potions. Okay, here's the years, which is X. Okay. At 0 years, Care of Magical Creatures has 60 kids and Potions has 40. 1 year later, we lose 5 from Care of Magical Creatures, so it goes from 60 to 55. We gain 15 in Potions, so 40 plus 15, that's 55. So what we're looking for is when they have the same number of students at the same time. That's why we got 1. Ta-da! So now we need a sentence. So we just put that into words. We say, at 1 year, Care of Magical Creatures and Potions will have the same number of students. That's it. Let's look at Hermione. So the last one. Okay. Struggling. All right. Hermione is buying and selling. Ooh, I can tell right there. I'm going to have to watch my signs. I'm going to be looking for pluses for buying and negatives for selling. Whoops, no, opposite of that. Opposite. Buying costs money. I wish that wasn't true. I wish every time I bought a pair of pants, like Amazon gave me money, but that's not the way it works. Okay. Buying is negative, selling is positive. Got that straightened out. Okay, so she's selling gently used quills for $12 each. So she's going to make money on the quills. Okay, and then it's each, so that one gets an X. She sells a time turner for $100. So that's also going to be positive. But she's only got one of those, so it's not like per time turner. It's just the one time turner. So no X. Okay, purchases a cauldron for 36 bucks. That's negative, but it's just the one, so we don't put an X on it. Okay, she's going to earn a total of $208, so that's going to be a positive 208. All right, so the question is, how many quills? How many quills did she sell? So we had better let X be quills or we're going to be solving the wrong problem. Let X be quills. All right, so let's add everything up. We know on the total side we've got $208 that she's making. Okay, so she's selling the quills, 12X, that's positive. Selling the time turner, plus 100. Buying a cauldron, negative 36. That's our equation. So now we have some terms to combine. We've got 100 minus 36. 100 minus 30 is 70. Take away 6 more, 64. So 12x plus 64 equals 208. Now we can subtract 64 from both sides using our subtraction property of equality. These cancel, and I get 12x equals, 8 minus 4 is 4. 20 minus 6 is 14. 144, a gross. So we divide both sides by 12, and we get x equals 12. So all we need now is a sentence. Remember that X is the quills. So we know that Hermione sold 12 quills to make $208. Ta-da! We're done.